Welcome to Breaking News to Trading Moves.
Glad to be here.
So, for you listening right now, our mission today is very direct. We are reviewing a specific acquisition headline that just crossed the wire. We're evaluating the immediate market reaction to that news, and we are identifying the specific winners and losers in the stock market as a result.
Yeah, keeping it strictly to the numbers and the market mechanics.
Exactly. So the headline we are focused on is this. ON Semiconductor is acquiring Synaptics in a $7 billion all-stock deal.
Right, a massive transaction.
It is. Now, to be absolutely clear right at the top, we are keeping this grounded.
Yeah, we have to.
We are simply looking at the transaction details and exploring where capital might rotate next. Meaning, this single deal does not change the world.
No, not at all.
And it does not alter the fabric of the tech industry. We're just looking at the math, the market reaction, and the companies involved.
Yeah, I mean, when you're looking at a $7 billion transaction, the most practical approach is really just mapping the mechanics of the deal itself,
Yeah.
We need to see what it tells us about current hardware priorities. And the fact that it is an all-stock transaction, that is key.
Yeah, that really changes the dynamic.
It does. That immediately dictates how the market processes the information and how it prices the assets of both the buyer and the seller.
Well, let's examine that immediate market reaction because it was sharply split the moment the news broke.
Oh, totally split.
On one side, Synaptics surged. And, I mean, that makes sense, right? The market priced in the expectations of a deal premium for the company being acquired.
Exactly, they get the bump.
But conversely, ON Semiconductor sold off.
Yeah, they took a hit.
Right. The market reacted to concerns about share dilution, the risks associated with integrating two complex platforms, and questions surrounding valuation discipline. It really reminds me of buying a new house.
Well, that's a good way to look at it.
Yeah, because for the buyer, your bank account takes an immediate, highly visible hit. And suddenly you have the burden of maintenance and moving costs for a new property.
You're just staring at the expenses.
Exactly. Meanwhile, the seller is popping champagne because they just collected a premium.
Yeah, get to walk away with the cash, or in this case, the stock premium.
Right. But looking specifically at the corporate finance level, why do buyers in these types of all-stock M&A deals often face such immediate downward pressure on their stock price?
Well, it's because the market prices in the math of share dilution instantly.
Okay, walk us through that.
So when a company executes an all-stock acquisition, they are not using cash from their balance sheet to buy the target company.
Right.
Instead, they are issuing brand new shares of their own stock to give to the shareholders of the company they are acquiring.
Ah, I see.
So if you are an existing shareholder of ON Semiconductor, your percentage of ownership in the company decreases the moment those new shares are created.
Because the pie just got bigger.
Exactly. Your slice is suddenly smaller.
Ah.
Furthermore, you have the mechanics of merger arbitrage at play.
Oh, right. Explain how that mechanical trading works for the listener.
Yeah, so institutional traders often buy shares of the target company, in this case, Synaptics. And they do that to capture the spread between its current trading price and the final agreed-upon acquisition price.
Okay.
But simultaneously, they short the acquiring company ON Semiconductor.
Wait, they short it?
Yeah, they short the buyer to hedge out broader market risks. So that predictable trading pattern creates artificial selling pressure on the buyer's stock right out of the gate.
Wow. Okay, so it's basically a structural trading mechanic forcing the price down.
Exactly. And beyond the structural trading mechanics, there is that integration risk you mentioned earlier.
Right, the new house maintenance.
Exactly. Merging two large semiconductor platforms requires navigating corporate culture clashes, combining disparate sales teams, and integrating highly technical software and hardware systems.
It's not just plugging one company into another.
No, it's incredibly messy. Investors demand a discount to take on that execution risk, especially when the buyer's paying a premium.
That makes total sense. So now that we understand the cost of the transaction and that initial market reaction, we need to examine exactly what ON Semiconductor is buying for $7 billion.
Okay, what are they actually getting?
Yeah, and which companies benefit from this specific market rotation.
Yeah.
Because ON Semiconductor is traditionally known for power management, right?
Yes, they make the components that regulate electricity in electric vehicles and industrial machinery.
Okay.
Yeah.
But Synaptics, on the other hand, made its name in human-machine interfaces like touchpads and display drivers.
Yeah, but lately they've been investing heavily into edge computing and wireless connectivity.
Right. So what's the logic here?
The underlying strategy driving this combination is that artificial intelligence demand is expanding.
Okay.
It is no longer confined to just cloud training chips sitting in massive data centers. We are seeing a movement into edge devices, automotive systems, industrial automation, robotics.
And connected infrastructure.
Exactly. ON Semiconductor wants to become a full-stack physical AI enabler.
Physical AI enabler.
Yeah. They plan to combine their power management, sensing, and imaging capabilities with Synaptics interface and edge compute capabilities.
Okay, I have to push back on some of the marketing jargon here.
Fair enough.
Is physical AI just a rebranding of the Internet of Things with artificial intelligence slapped on top to make it sound newer?
I mean, it sounds like corporate spin, I'll give you that.
Right.
But there actually is a structural difference in the architecture. The Internet of Things was primarily about connectivity.
Like smart thermostats and stuff.
Exactly. The goal was putting a Wi-Fi chip in a thermostat or a sensor on a pipeline so it could send raw data back to a central server.
Okay.
The server did all the computing, and then it sent a command back. But what separates this current phase is the location of the computing power.
It's moving closer to the device.
Yes. Instead of just sending data away over a network, the device itself has the embedded compute power to process the data locally and make a decision instantly.
Ah, eliminating the latency of a round-trip network connection.
Exactly. Latency is the whole game here.
So, to use a biological analogy, the massive data centers we have been hearing about for the last 2 years are basically like the brain.
That's a great way to think about it.
Right, because the brain processes vast amounts of information, learns over time, and stores complex memories. But this edge computing push, the physical AI, is more like the nervous system and reflexes.
Yes, exactly.
Like, if you touch a hot stove, your hand pulls away instantly because the reflex is processed locally in your nervous system.
You don't have time to think about it.
Right. You do not wait for a signal to travel all the way to your conscious brain, run an analysis on the temperature of the stove, and send a signal back down to your arm telling you to move. By the time that happens, you are burned.
That analogy captures the technical reality perfectly.
Yeah.
Yeah, because in an autonomous vehicle or a high-speed manufacturing robot, latency is the enemy.
Makes sense. A car can't wait for a cloud server to tell it to brake.
Exactly. A robotic arm moving at high speeds on an assembly line cannot afford the millisecond delay required to send sensor data to a cloud server just to determine if a human has stepped into its path.
Wow. Yeah. It needs to react right then and there.
It needs a local processor right there on the hardware to trigger an immediate halt, and that requires a very specific type of semiconductor architecture.
One that manages power efficiently.
Yes. Manages power efficiently, processes inputs instantly, and operates reliably in harsh physical environments.
Okay, so let's break down the specific winners in this environment by following the life cycle of that data.
Let's do it.
First, we have the Edge AI category. The companies that benefit as data processing moves locally to devices include Synaptics, ticker SYNA, and ON Semiconductor, ticker ON. They're positioned to provide the actual edge processors.
Right.
But before data can be processed, it has to be captured. And that brings us to the automotive and industrial sectors.
This is where it gets really compelling.
Yeah, because vehicles and factories need edge intelligence, sensor fusion, and real-time processing, driving demand for analog and power management chips.
Absolutely.
The winners here are Analog Devices, ticker ADI, and Texas Instruments, ticker TXN.
Yeah, those two are perfectly positioned.
Walk us through why analog chips are so crucial to this physical deployment.
Well, to understand why Analog Devices and Texas Instruments win here, you really have to look at how data actually moves.
I'm okay.
The physical world isn't made of ones and zeros. It is analog. It is heat, pressure, or motion.
Right.
To get an artificial intelligence to understand the physical world, you need a mixed signal chip.
And what does that do exactly?
That chip takes the physical input, like the temperature of an industrial boiler or the pressure on a brake pedal, and translates it into a digital signal the processor can compute.
Oh, so it's the bridge between the physical and digital worlds.
Exactly. As factory automation increases, the density of those specific analog chips per device skyrockets.
And that leads directly into the concept of sensor fusion in automotive applications.
Yeah, sensor fusion is massive right now.
Because it isn't just bolting multiple cameras onto a car bumper, right? It is the embedded processor's ability to stitch together radar, LiDAR, and optical video in real time.
Yes.
So the vehicle actually knows the difference between a shadow and a pedestrian.
Exactly. And doing that requires massive amounts of immediate localized power and data translation.
Which again points right back to the product catalogs of Texas Instruments and Analog Devices.
Correct. They own that space.
Okay, so once that data is captured and processed locally,
Mhm.
an action has to be taken.
Right. The machine has to actually do something.
And that brings us to our third category of winners, automation and robotics. Smart manufacturing relies on precise controllers central to this physical AI push.
Mm-hmm.
The winners in that space are Teradyne, ticker TER, and Rockwell Automation, ticker ROK.
Yeah, Teradyne is a really great example here. Well, they build collaborative robots, often called cobots, which are designed to work alongside humans on a factory floor.
Okay, so they're not behind a safety cage.
Exactly. If a human steps too close, the robot needs to adjust its speed or stop entirely.
Right, relying on those fast reflexes we talked about.
Yes. The localized compute power allows these machines to run complex spatial algorithms on the chassis itself.
Wow.
The more advanced the edge computing hardware becomes, the more capable and autonomous companies like Teradyne and Rockwell Automation can make their industrial systems.
That makes a lot of sense. Now, because capital is finite, a rotation into edge computing naturally means capital is rotating away from somewhere else.
Right. Money has to come from somewhere.
And consolidation also naturally squeezes out smaller players. So let's look at the losers in this scenario.
Okay.
We should start with the data center AI rotation risk. Investors may temporarily reduce exposure to pure data center AI beneficiaries as capital moves toward edge deployment.
Yeah, we are seeing some of that happen.
The names facing that specific pressure are NVIDIA, ticker NVDA, and Advanced Micro Devices, ticker AMD.
Mm-hmm.
Now, if you are listening to this and looking at your portfolio, you are probably wondering if you should be concerned about holding these stocks.
Naturally.
I mean, are NVIDIA and AMD actually losing here, or is the market spotlight just temporarily panning away to focus on the hardware executing the AI locally?
It is entirely a mechanical market action. It is not a judgment on their product pipeline.
Okay, that's an important distinction.
It's crucial. You really have to separate a company losing its underlying business value from a temporary capital rotation.
Right.
NVIDIA and AMD are not losing market share or facing a sudden drop in demand for their data center graphics processing units simply because ON Semiconductor bought Synaptics.
Their business models are fine.
Their business fundamentals remain exactly what they were yesterday. However, the stock market operates on capital flows.
Right.
Many institutional investors and portfolio managers have heavily concentrated, highly profitable positions in those pure data center names.
Because that is where the growth has been over the past several quarters.
Exactly. Their portfolios are overweight in those specific areas.
So if a portfolio manager gets the signal that industrial edge computing is the next deployment phase, they need cash to buy into names like Texas Instruments or Teradyne.
Spot on. And to get that cash, they trim their highly profitable positions in crowded trades.
I see.
They might sell a portion of their NVIDIA or AMD holdings to fund the new positions.
So the stock price of those data center companies experiences downward pressure, not because their business is failing, but because traders are taking profits to allocate money toward the physical layer.
That is exactly what is happening.
Got it. Let's move to the niche competitors who are facing pressure.
Yeah, the smaller players.
Smaller companies like Ambarella, ticker AMBA, and SiTime, ticker SITM, face pressure as larger players consolidate sensing, compute, and connectivity into single platforms.
Mm-hmm.
How exactly do these specialized companies get squeezed out of the market by a merger like this?
It really comes down to the mechanics of vendor reduction and complex supply chains.
Vendor reductions.
Yeah. Take Ambarella, for example. They design incredibly efficient, ultra-low power computer vision chips.
Okay.
They are technologically excellent. And SiTime designs precision timing oscillators that keep data synchronized across a motherboard.
Right.
Historically, if you were an automotive manufacturer building a new dashboard interface and sensor suite, you had to buy a vision processing chip from a niche company like Ambarella,
Okay.
a timing chip from SiTime, and a power management system from a third vendor.
Wow, that's a lot of separate pieces.
It is. Your internal engineering team then had the burden of making sure all those different components work together perfectly without bottlenecking the system.
Which requires extensive testing and creates multiple points of failure.
Precisely. It's a huge headache.
Right.
So when a massive player like ON Semiconductor acquires a company like Synaptics, they can walk into that automotive manufacturer and offer a single, unified platform
That handles everything.
that handles the power, the sensing, and the interface all at once.
Wow.
It is pre-integrated, guaranteed to communicate seamlessly, and often cheaper because of bundled pricing.
So the smaller niche players simply cannot compete with that level of convenience and scale.
They just can't. The automotive manufacturer would rather buy one integrated board than piece together 5 separate best-in-class chips and take on the integration headache themselves.
That makes total sense.
Uh-huh.
But that dynamic also introduces the acquisition and integration risk for the larger players trying to build these bundled platforms.
Oh, absolutely. The risk just shifts to the acquirer.
Right, because shareholders of ON Semiconductor, ticker ON, and their direct competitors like ST Microelectronics, ticker STM, face pressure from the execution risk of combining complex semiconductor platforms.
Yes, and that risk is very real.
How often do these semiconductor mergers actually deliver the synergies they promise on day one?
Historically, synergy delivery timelines slip frequently. Yeah, because semiconductor supply chains are highly rigid. You are dealing with multi-year tape-out cycles for new chips, specific manufacturing agreements with foundries, and highly specialized engineering teams.
It's not a fast-moving software update.
No, not at all. When you merge 2 companies of this size, you risk disrupting that entire ecosystem. If an acquiring company pays a premium for the target, they are mathematically relying on capturing new market share or cutting redundant costs within a specific time frame to justify the price tag.
Right, the clock is ticking.
Exactly. If platform integration takes 3 years instead of 18 months, the return on invested capital plummets.
And traders know this.
Traders absolutely know this, which is why the execution capabilities of ST Microelectronics and ON Semiconductor will be heavily scrutinized over the next 4 quarters.
Well, tying these specific stock movements together helps us establish the broader takeaway for traders looking at the semiconductor space right now.
Yeah, we have to look at the big picture.
AI expansion is entering a second phase. We are transitioning from training large models in hyperscale data centers to deploying intelligence into physical systems for real-time decisions.
Exactly.
The market is now pricing in where AI demand physically lives. We also must remember that execution risk remains historically high for semiconductor mergers and acquisitions. This transaction will likely trigger further consolidation across analog, power, and edge compute players as scale becomes critical for winning those lucrative automotive and industrial contracts.
It's going to be a fascinating space to watch.
Truly, trading this news is not just about analyzing the buyer and the seller. It is about recognizing a broader capital rotation from infrastructure development to physical deployment. We are watching the focus move from building the data center brain to outfitting the industrial nervous system.
That transition opens up an entirely different segment of the hardware market to capital inflows.
Yeah, it does.
As we watch this play out, my final question to ponder is this. If scale is now completely mandatory to win industrial and automotive contracts, which niche edge computing startup is the next acquisition target?
Ooh, that's a great question.
Right. I mean, will we see an absolute frenzy of legacy hardware companies buying up smaller players just to stay relevant in this second phase of AI deployment?
I guess we'll just have to wait and see.
We sure will.
This is not financial advice or buy or sell recommendations. This is purely the opinion of the author.
Exactly right.
Well, thank you so much for joining us for this review of the headlines and the market mechanics behind them. We appreciate your time, and we will talk to you next time.